responding to the challenges of climate change. Uh, I'll start with because most of the slides are based on the climatology of Sri Lanka and climate zones of Sri Lanka. So I would like to explain very briefly the climate season and climate zone in Sri Lanka. So in Sri Lanka, we have 4 climate season: the March, April, the first intermonsoon, then second intermonsoon, second southwest monsoon from May to September, and second intermonsoon October, November, and northeast monsoon December, February. And based on the spatial annual rainfall distribution, country can be divided into 3 zones: the dry, intermediate, and wet zone. The dry zone is dry zone is the most agricultural practices are going on in the dry zone, and the rainfall is less than 1,750 millimeter annually. And these are the observed change. Actually, Dr. Punyavardhana also explained this everything, but I briefly explained the average temperature has been increased as a global level, and no significant annual rainfall change, but high rainfall variability. So you can see some of the observation we identified, and increase of extreme rainfall events. So this is the recent analysis done by myself and one of our researcher. So you can see the recent decade. So most of the extreme events observed in recent decade. So I would like to move for the future projection. My presentation is more focused to future projection because Dr. Potivarandra already explained the current situation. So when we talk about the temperature, we analyze that climate change sector in my department analyzed future scenarios for future projection for 2 scenarios. The one is moderate emission scenario, that is RCP 4.5, and the other one high emission scenario, RCP 8.5. So you can see by 2090, so in Sri Lanka, temperature can be increased by 1.9 to 2.7 degrees. It is based on that the emission level. And the below table, actually I have done very recently for one of the project in UNDP. So you can see this is target to Trincomalee. It is in dry zone, the eastern province and coastal eastern coast. So you can see the temperature can be increased by 2.2 for the moderate emission scenario and 3.7 for the high emission scenario. So the interesting part is this one actually. I just divide into 4. I just analyze the increase in temperature for monsoon in Sri Lanka. So you can see the first winter monsoon, the temperature increase is very much higher than the other seasons. So you can see even for the next 2 decades, 2021 to 2040, the temperature can be increased by 2.6 degrees for the low emission, medium, moderate emission scenario, and even it is almost same for the high emission scenario. But when you go to 2100, it is much higher. It is much higher in much higher for the high emission scenario. So even that the temperature increase, this much increase for the first winter monsoon, it can be extended even for May and June and even July. So I just focus this analysis only for different seasons, right? So increasing temperature and extremes, the more so we need more energy, right? In that case, we emit more greenhouse gas because we have to use more power, and more heat-related health issues also expected with this extreme. That high temperature, high extreme temperatures, and we'll just move to the annual rainfall budget in Sri Lanka. So this is actually I got from one of the irrigation engineer. So you can see. So when we just take as that the water received from that rainfall, it is 100 millimeter, 100%. Actually the average annual rainfall is 1861, and the average evaporation is 3 millimeter per day. But when it convert into the annual, when it convert into the annual, will be it will be 1900 1095 millimeter, and it is almost 58% from the annual rainfall. But so it is very clear, with the high temperature more evaporation can be taken place. With that, when we average evaporation as 4 millimeter per day, it will be 1460 millimeter, and it will be 78% evaporation with the with the uh, receiving rainfall. So some actually we observed that some year, especially during March, April, the evaporation is much higher than 4 millimeter. So that will be highly impacted for water resources in Sri Lanka. And now we'll move to the rainfall projection for the next 100 years. So you can see, so this analysis has been done for different 4 seasons in Sri Lanka: the first inter monsoon, southeast monsoon, second inter monsoon, and northeast monsoon. So you can see, and also this has been done for different 2 scenarios, that is 4.5 moderate emission scenario and high emission scenario. So you can see the first inter monsoon, the rainfall will be negative. I mean, the negative anomaly, we can observe a negative anomaly rainfall for the next years. I mean that until 2090. But you can see for the southeast monsoon rainfall, southeast monsoon season, the rainfall will be the positive. I mean that we get high. I mean that high amount of rainfall. And even the second inter monsoon, the rainfall is much higher. That is positive anomaly. But the northeast monsoon season, the rainfall will be negative. So, so when we just focused the focus for the dry zone, because actually we are much focus into agriculture, because agriculture is one of the main I mean the livelihood option in Sri Lanka, and you know that it is one of the main economy. So so you can see uh, most of the agriculture practices are going in dry zone. And dry zone, so dry zone actually we get much rainfall for the dry zone area. Actually we get much rainfall during northeast monsoon. So you can see, so northeast monsoon actually we get from you know that in future, so we get less rainfall. So it is a very high impact for the agriculture. So even we get they get positive anomaly for the southeast monsoon season. I mean that northeast dry zone. So the contribution for the monthly contribution is very much low for the dry season, dry zone, because so monthly actually the monthly contribution is 4%. So you can see, when we just focus into the dry zone, uh, from first inter monsoon to southeast monsoon, they don't get much rain, and the soil will be much drier. And even second inter monsoon they get high rainfall. So it will actually that's during the second inter monsoon. So we get that thunderstorm type rainfall, the convective type rainfall, and we get high intense rainfall. So because of that, that more runoff will be taken. And also uh, the more absorption, more infiltration also taken place. So because of that, if uh, if you get that no low rainfall during northeast monsoon, it is a high impact for water resource in north dry zone, as well as it will impact for the agriculture practices. Right. So now we'll move to the extreme events. Actually, we are more talking about extreme events, because extreme events are uh, the most problem for the water resource. So you can see the dry zone, wet zone, and dry intermediate zone. So extreme rainfall. This is based on percentile-based rainfall. Heavy rainfall events and very heavy rainfall events can be increased. This is done for 2021 to 2100. And for the moderate emission scenario, and even for the high emission scenarios, it is almost same. And this is for different monsoon seasons. You can see the southeast monsoon, northeast monsoon. So I mean that extreme rainfall, the so I mean that it is increasing, and it is very significant. The p values are that almost 0. So this is the scenario for the future about extreme rainfall events. And with increasing of heavy rainfall events, leading to an increase of floods, landslide, and also soil erosion, more runoff, and less infiltration, and also increase the frequency of dry periods and droughts. So you can see when we just focus into the water budget in Sri Lanka, so runoff is just 37%, but with the high intense rainfall and extreme rainfall, this part also be increased. So it also be a high impact for water resource in Sri Lanka. So just that my analysis part is almost finished. I would like to way forward. So climate projection indicated dry zone will be further drier, especially dry in Maha season. With higher Maha season means the major cultivation season in Sri Lanka. It is going on from September to February. So dry in Maha season with higher impacts in the northeast and the east, where agriculturally intensive areas are located and are already experiencing water stress, and more evaporation taken place, and more runoff and extreme rainfall and soil erosion. And the expected change may lead to an increase in the Maha wet season, irrigation water requirement for paddy by 30% to 23% by 2050 compared to 61 to 1990. That is our normal climatological season 61 to 90. And this is the final slide. Actually, for the way forward, actually, I would like to explain this one on top of the extreme rainfall and change of rainfall pattern. So what we observe, the change of monsoon season. So first winter monsoon, where the yellow season, the first agriculture season start, it is just shifted towards end of March, right? Even now we are experienced that. So you can see that you can compare the that expected rainfall in future and the shift in the onset of monsoon season. So that will lead the less rainfall in March and more rainfall in April. But combined March and April rainfall, even it is less than the average. And southwest monsoon, there are no problem. And even southwest monsoon, second winter monsoon is not much problem, but shifting the onset of second winter monsoons towards October, it will be a problem for the agriculture season, because September, October actually, so we start the Maha season. So Maha season will be little late. So with these changes, comprehensive analysis has to be done with real ground observation, and we have to apply adaptation strategies. So thank you very much.